Homework pressure? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
All right, welcome back. For this problem, we've got two special vectors here. So the first one, which I will call f sub a. There we go, now it's kind of an a. Has a magnitude of, has a magnitude of 90 newtons in the eastern direction. F sub b goes something like that. Forms an angle of 75 degrees with a positive x-axis. It has a magnitude of 135 newtons. Call that f sub b. So in this problem, we want to find what is the vector a minus the vector b. Also, what is the vector b? Oops, I have drawn that too high up. There you go. Maybe move it a little bit further. Oh, that's about as far as it goes. All right. Minus the force vector a. All right, so to do that, first we need to find the x and y components of f sub b. So its x component is equal to 135 cosine of 75 degrees, which is going to give us about 34.94 newtons. The y component is going to be 135 times the sine of 75 degrees. That is going to give us 130.4 newtons. All right. I guess this should be a 4-0. Keep the number of significant digits equal in both of these components right here. Let's find f sub a minus f sub b. So if we find the x components there, so f sub a has a positive x component of 90 newtons. So we're going to do 90. And then f sub b also has a positive x component, but since we're subtracting it, it's going to be minus 34.94. And that is going to give us a magnitude of 55.06 newtons. All right, to the y component, f sub a does not have a y component, so that makes this rather simple. It's going to have then the same y component, but in the opposite direction because we're subtracting f sub b. All right, so we can find the magnitude of that by f sub a minus f sub b. The magnitude of that, using the Pythagorean theorem here, 55.06 squared plus 130.4 squared. That magnitude is going to be 142 newtons. And we can find the angle theta that it's going to make with the x-axis. Theta is going to be arctangent of the y component over the x component, opposite over adjacent. Which is going to give us about 67.1 degrees. All right, so if you're kind of imagining this, I should have drawn a picture first. We got the f sub a and here's f sub b, and so the resultant vector is going to look something like this. Just like that. All right, let's draw a diagram for this one, since we didn't do it on the last one. So we've got f sub b minus f sub a. So we're going to draw f sub a starting at this head right here, but we're going to draw it in the opposite direction that f sub a it actually is. So we're going to draw it like this. That's going to give us a resultant vector that looks something like that. All right, so we already have the values we actually need for this. If we want to find so this will be a little bit faster, I hope. The x components, we've got a plus 34.94 newtons from vector b, minus 90 newtons from vector a. That is going to give us negative 55.06 newtons. The y component is going to be positive this time because f sub b is in the plus direction now. Finding the magnitude of that using Pythagorean's theorem. We're going to get the same answer as before, so it's going to have the same magnitude, this resultant vector right here. Same magnitude. And it's going to form the same angle too, but it's going to be along from an angle north of the negative x-axis instead of south of the positive x-axis. All right, so there are your answers. I'll box both of them even though they are the same. I guess I should write out here that, oops, this right here is going to be south of east. This is going to be north of west. All right, and there are your final answers.